Hey there, Course 3. Super important lesson today called Direct Variation. You're going to see a lot of this at the next level. This book will start to really hit it too. And the big equation that we use with direct variation is this guy right here. Y is kx. One way to kind of understand how this equation works, in a proportion, like 1 over 2 equals, I don't know, over 4. Let's use a y there to help us understand direct variation. We can cross multiply. We can also solve by going, what's being multiplied by my number to get to 4? Okay, it's a 2. It's going to follow what's called a constant of proportionality to find this. I'm multiplying, let's call this x, times a constant 2 to get y. And in this equation, x is 1 times the constant of proportionality, which we call k. Don't ask me why they use that letter. This gives me y. Okay? You can rearrange this equation a little bit. Divide both sides by x, which moves x basically over here, but underneath. You can also say k is y divided by x. If you're solving for the constant, then you'd have y divided by x gives you k. So a direct variation relationship or proportion means that you have an input multiplied by the same k every time, always gives you the output. A great example of this would be kind of like perimeter is always the side length of a square times the same constant, which is, well, if it's a square, it's always the side length times 4. Perimeter of a square is a direct variation problem. Perimeter is k times x. So as long as I know that this is 9, that's all I need. I put 9 in for x, or s in this case, and I multiply 9 times 4, 4 being the constant, and I get 36 is k times x. It's a direct variation problem. Okay, it's going to get a little bit more weighty here. When one variable is 0, the other is 0. Meaning, if I put 0 in for anything in a direct variation, so if the input x is 0, then no matter what this constant is, it doesn't matter, right? Because we're multiplying by 0, the y will be 0. So if it's following this format in your t-chart, 0 should always shoot out a 0. Meaning when you graph direct variation, it should be a straight line and it should go through the origin every time, because 0, 0 should always hold true in these relationships. Another thing that's true in direct variation, number 2, as one variable changes, the other changes by a constant factor, which means what you end up with is a straight line. Okay? If you ever see a graph and it asks, is this direct variation? No, because that's not a constant. It's accelerating or it's exponential. This is not going in a straight line. This is not direct variation. It needs to be a straight line and it needs to go through 0. If you're looking at just the graph, those are your telltale signs. Without graphing, example 1, it just says which of the following is direct variation. They help by underlining what are the variables. A taxi company charges $3 to start the ride plus $2 per mile. So that'd be D equals 2 times M, and then the 3. The plus 3 is the $3 to start. Okay? A equals S squared. That's the area of a square is side length squared. And then perimeter of a square, I've already given this away, but that's 4 times side, right? So a great way to understand which one's direct variation, just create a little chart. Maybe make 4 rows. to sort of watch for the pattern, and then just do 1, 2, 3, 4 if that makes sense. What if it was 1 mile? What if it was 2 miles? What if it was 3 miles? Okay. Well, you start with the $3 charge, and it's $2 per mile. So $2 for 1 mile is 2, plus the 3 that starts it is 5. Okay. 2 times 2 is 4, plus the 3 is 7. 2 times 2 is 4, plus the, 3 times 2 is 6, plus the 3 is 9. And then 4 will be 11. Okay. So you could even have a column that shows the proportion, or you could just be watching, is this always being multiplied by a constant? It doesn't look like it, right? Since these aren't all nice even numbers, it's probably easier just to do 5 divided by 1. Probably comes out, well, that's 5. And then just do 7 divided by 2. What decimal do you get? If it's not 5, then this is not a direct variation. Okay, put in 1 here. 1 squared is 1. 2 squared is 4. I've already busted the proportion because 1 times 1 is 1, but 2 times 1 is not 4. So this is not direct variation, and anything with a square won't be, because those graphs always end up curved. All right. In this case, 1, 4, 2, 8, 3, 12. You're going to get a nice direct variation problem here. Next relationship, times 4 every time, right? And it so clearly follows the pattern, right? Really, x is the s. You got the k is 4, and the y is the perimeter. The only example of direct variation is the relationship between the perimeter of a square and its side length. Okay. They talk about the graphs again here. Quantities that are direct variation, or quantities which vary directly, means the same thing, have pairs of points which lie on the same line, straight line, and that line intersects the origin. Let's read this part here. In a direct variation relationship, the value of one variable depends on the value of the other. One variable is independent, one variable is dependent. And in our examples here, to me, it's the x is independent. That could be anything, right? Y depends on x. If x is 2, then y is, 4. And if x is 3, then y is 6, or whatever. So y is, I think, the dependent in our traditional direct variation equation, and x is independent. In example 2, we have somebody doubling every number that someone says. So she says 2, he says 4. She says 1, he says 2. Doubling means timesing by 2, so I'm pretty sure this is going to be direct variation. What's the constant? Well, if he's doubling every time she says x, he doubles it, right? So the constant of variation, or the k, is 2. If we want to use variables that fit this particular problem, we would say 2 times every number that Eunice says is the number Doubleday says. So that we can clearly identify who's who. We use the first letters of their name. And that's what the graph would look like if we made up a t-chart. $12 an hour. Create a table that shows the first 4 hours. Okay, the pay being 12. Then after 2 hours, it's 24. 3 hours, 36. Very basic equation here, right? His pay is his number of hours times 12. The constant of proportionality is 12. Kind of making sense? I know it's a little bit longer, more in-depth video. Why don't you try A, B, and C so we can really work on this?